Are you building full-stack applications using TypeScript that require a backend and where you or your team have full control of the API? If that's the case, then you might want to consider using tRPC to build out your API and to manage your API client interactions. tRPC is a great alternative to existing solutions like GraphQL or REST API, but it provides type safety by default and allows you to iterate incredibly quickly. As with many topics, tRPC is incredibly simple once you understand it, but there's a bit of a conceptual barrier to entry. If you're using tools like the Create3 app, for example, which I introduced in my previous video, you already have your entire project set up with the code split across multiple different files, which makes it quite difficult to get an overview initially. So today, we will get over that initial barrier of entry by going over the tRPC website and creating a few examples of our own. By the end of this video, you will be able to use tRPC in any full-stack application, and you will have a solid foundation to dig deeper into the tRPC documentation on your own. So as always, grab a drink and let's write some code. All right, let's have a look at the tRPC documentation. Funny enough, the tRPC landing page is significantly better at explaining what tRPC does and how it's used than the getting started part of the documentation. So let's actually start with the landing page itself. As they already say, the main value in using tRPC is that you have end-to-end type-safe APIs, and they're very easy to set up. So what tRPC brings to the table is a server-side implementation and a client-side implementation, which is used to query your backend endpoints. They provide an example right off the bat here, which I actually find very well done. So let's open that up in a new tab so you have the control over it. On the left-hand side, what you see is the server-side implementation. So this is how your backend endpoints are implemented. As you can see, you initialize a tRPC instance by calling the create method on the tRPC server package. Then you have your router, which essentially manages all of your different endpoints that your tRPC server implementation will have. So you have one tRPC instance, and that one tRPC instance may contain multiple different endpoints. In this case, we only have a single endpoint called greeting, and every endpoint is essentially defined as a type of procedure. Every procedure can have an input. So an input is something that you would usually have, for example, in a GET request in form of path or query parameters, and on a post request or update request, for example, could also be contained in a body. tRPC really doesn't make that distinction, but instead you have the input and you define the shape of the input. This is great because on the one hand, your handler knows exactly what it will get and you don't need to do any sort of type checking in the handler itself. And also this type will be used on the client side, so your client always knows what the server is actually expecting every request to have. Now, in this specific example, and in most examples that I've seen, they use a third-party library called Zod to actually do the input schema validation. There are also a few other libraries that they support, among which, for example, is Yap. And you can also build your own custom validators. But from what I've seen, Zod is super intuitive to use, and you will see most examples actually using it. So personally, unless you are already super familiar with something like Yap and you just want to continue using it, I definitely encourage using Zod to do your input validations. And also this is used to really generate the schema that your query will then be able to use. Then we actually have the handler. And if you're familiar with GraphQL, you are already familiar with the concept of mutations, which do some operations on your data, change the data that's persisted on the backend, and queries, which is simply like a GET request, essentially. In this case, they have a query handler implemented, which just checks if the input actually has the message property, and it would respond with an object where the field would message, or MSG, would contain a string, which would either be hello and the message that the client provided, or it would be hello world. Now that's already mostly it in terms of implementation on the server side. All that's left to do is export the type of your app router, which is what your tRPC client will use to infer what sort of inputs and outputs your individual tRPC endpoints will provide or require. On the client side, you have the tRPC client package which is used. And we also import the types that we exported here from our app router. We initialize our tRPC proxy client in here, and there are different ways of doing that. And there are some properties which we'll go into later. But the most interesting part is actually down here, where you have a tRPC request. And essentially what happens here is you use the tRPC client, you call greeting, which is our endpoint we defined on the backend, and you perform the query operation on it, which we defined as well on the backend. We provide the message John. So when we get the response, we actually expect this to be hello John, which is what we defined on the backend. Now, this is all well and good. You already see the type completion over here, so you already know what the response shape will look like. We expect to have this message property no matter what. Now, what happens if we actually update something on the server side? So on the server, for example, we change the input field from, I think, originally message to name, and we update that on the server side. Now, what you see here, and this is pretty well highlighted, is that the client immediately, without any sort of code generation, knows that this field has changed. It's no longer called message. Message doesn't exist anymore. It now expects a field called name. So your code editor will automatically provide you hints that your code is no longer valid, and it actually won't compile if you try to compile it. So this really guarantees that any changes you perform on the back end will also be reflected on the front end. And as soon as you fix it, you also have type completions. So it's very easy to do a lot of changes on the back end, do different sort of nestings on your data, and you can still be sure that it works on the front end. Also, what's interesting is compared to, for example, something like your typical REST endpoints, you don't need to worry about some sorts of routes. Those routes that you define in your app router will automatically be carried over to what your client object looks like. So you can also reconfigure that as needed, redefine namespaces, etc. So on a very high level, that's all there is to tRPC. And we will go into the individual concepts now by looking more at the documentation. But before we dig deeper into the tRPC documentation, let's take a moment to build out an example application by implementing what we've learned just by looking at the tRPC showcase. So to get us started, I've created a new directory and initialize it with npm. What we need to do now is they run npm install to include all of the necessary packages. At the bare minimum, we need the tRPC server and client packages to specify each respective side. We need Zod to do our input validation, and we will use Express to set up our Express web server. That will take a moment to install. All right, and once it's done, we can dig into the code. So I've already prepared a server.ts and a client.ts file. On the server.ts, we will implement the following use cases. We will have a list of users that we will be able to fetch. We will be able to fetch a user by a provided ID. And we want the ability to create a new user. So let's set up our initial user definition. So we have the user type, which consists of an ID and a name. And we already have a list of users, which already includes a very first user called John with the ID of 0. Now to set up our tRPC server instance, let's call init tRPC and not the context, but the create method, and assign this to a variable. So let's call this tRPC. Moving on, we need to define our tRPC router. So let's call this const app router and call tRPC.router. This will allow us to specify all of our endpoints. So we already defined that we will have 3 of them. We want to have the list users, which is some function that we'll specify in a second. We have get user by ID. And we have the create user, which will be a mutation. So the list user, all of these things will be tRPC procedures. So let's call tRPC procedure. And the first one, list user, will be a query. In this case, since we're listing all users, we don't need any information from the client, so we don't need any input validation, but we can simply define our query function. In this case, we will simply return the user list, and that's already it. So whenever the client calls the list users endpoint, it will simply return all of the users that we currently have in this array. The get user by ID is a little more complicated, since in this case we also have a tRPC procedure, but this time we have input validation. So within our input validator, let's use Zod to define that our input should always be of type object. And of course, we need to include Zod as a dependency. And this Zod object will consist of a single property, and this property will be ID, which is a type number in this case. And it is always required. So any Zod objects are always required by default, unless you specify them as optional or nullish. Next up, we define our query itself. And this query will have an input, or actually a request, and the request itself will contain the input. So we can get that by calling input equals request.input. Of course, we could already make our life a little easier by actually replacing request itself by destructuring it directly to input, and then we can get rid of this. So next up, we will just look at the list of users that we specified over here and return the first object that we find, where the user ID is equal to the input ID. And you already see the type completion here, because this type is inferred from the input validation that we performed in the previous step. Finally, in the create user procedure, we once again have to create a new procedure. And this time we need an input, because the client needs to tell us the name of the user that we are creating. So let's once again call Zod object. And in this case, we have a name, which is a Zod string. And since we are not just returning data, but we are actively updating data on the server, this time we will have a mutation function. And once again, we have our input. And we will create a new user. So let's create a new variable for this. The name we will directly take from our input.name. We can actually specify this of type user. And the ID should auto-increment based on the last user that we have. So let's get our, I think it's called user list. And then user list.length -1.id and add 1 to it. So now all we need to do is push that at the end of our user list. So new user. And we probably want to return the newly created user because the ID is server generated. So our client doesn't actually know the ID of that user unless we actively return it. So in this case, return new user. New user. Now that we have our app router configured, we actually need to inject it into our Express web server, because as we mentioned earlier, tRPC doesn't implement the web server or HTTP server on its own. So in order to do that, let's use Express and call and initiate our new Express app and import the Express dependency. We will also have our app listen on port 3000 and just console.log when that is finished. Finally, we need to inject our app router into the Express middleware. So for that, there is an adapter provided by tRPC itself, which is the tRPC Express adapter. In my case, Visual Studio Code doesn't automatically find the dependency, so I'll just copy it over from the docs. And in this case, it's at tRPC/server/adapters/express, and you import all of it. Finally, all that's left to do is define our app router type, which we will then use on the client side to know which endpoints actually require which inputs and what the expected outputs are. So we will simply define a new type and export it. That's it. We can now test our server by opening our console and running npm run server. App is running on port 3000, so that looks good. Next up, let's take a look at the client. The client is a lot easier to configure. All we need to do is create a new tRPC client. So let's call this client and create tRPC proxy client. And the client needs the type that we exported from the backend. So let's call the app router type and pass it as a template type. And what we also need to do as the single required property is define links. Links is essentially all of the different steps that your tRPC client will perform before querying the backend. The final link in that links chain will be the call, is called a terminating link, and will be the call to the backend. Since right now we don't have any other in-between steps, like logging, for example, we will just call the HTTP batch link function, and that receives the URL, which in our case is the HTTP localhost 3000, and we specified the tRPC path. What HTTP batch link does is it will automatically batch multiple tRPC requests that happen within a very short amount of time. That will reduce the overall network requests and significantly speed up the entire experience. Now all we need to do is call our 3 endpoints. So we will start off by querying a specific user by ID. To do that, simply call the client, and you see automatic type completion for our 3 functions that we defined. The first one is get user by ID, and then we perform the query operation on it. In this case, we already get a warning that we have some input parameters missing. So let's provide it our ID. And in this case, we will fetch the first user. This, of course, returns a promise. So we can use the then clause to console.log the user. We can actually call this get user by ID. We can do the very same with the create. So client.createUser. In this case, it is a mutation instead of a query. And we have to provide a name, which we already get type completion that, or type hinting, that number is not assignable to type string. So let's call this user Bob and update the console log with created user. Finally, we can query the entire list of users in which our newly created user should show up, as well as the first one that already exists. So get, what did we call it? Did we call it list users? Query. And this one doesn't take in any inputs. This will return users. And let's update the console log as well with list of users. Simple as that. All that's left to do is open up the terminal, open up a new window. The server is still running on this previous window. And in this one, call npm run client. We will see a warning because we are running this in a node environment where node fetch is not supported. Well, it's only supported as an experimental feature, but we see it working already. So we get a user by ID, we get a list of users, and we get the created user. Since these are asynchronous, they are dispatched together, and apparently the get user by ID and list users get executed before our create user operation. So what we can do is we can wrap this, our client, in a function. You can call this function main, make it async, and I guess the async goes before, and await all of these operations. And finally call the main function. Now if you rerun the client, we see that get user by ID, we get John, our newly created user is Bob, and a list of users will return Bob twice because we created in the previous pass and this pass as well. So all of it works as expected. There are a few concepts that we haven't touched upon yet, which are super critical to tRPC, and which I want to briefly introduce by going over the documentation. One of those concepts is, if we look at the tRPC docs, is the concept of a context. Now, the problem that context solves is that imagine you are on a typical Express server, and you have some middleware that authenticates a user, and you want to enrich a user object that then the subsequent handler can use. That's not super straightforward to implement. With tRPC context, it actually allows you to create an object, create a context, which will be passed down to all of your downstream handlers. So you can easily define a single piece of middleware that, for example, authenticates the user, sets up a session as provided in this example, and your downstream handler can easily use. Type safety included once again. Sadly, this is one of those scenarios where the tRPC documentation can cause a little more confusion than be super helpful. Really, what we can take away from here is what the context does, which is manage things like database connection and authentication information, and how to get started with it, which is that we need to chain or pipe the context function with the context type into our init tRPC before calling create. We also need to define the context function itself and add that when we define our Express middleware. So before we implement it on the server side, let's update the client to reflect what we actually want to achieve. So let's assume that with every request we pass in the current user ID. Of course, in a production scenario, you would probably pass a JWT of some sorts for authentication, but just to keep things simple, let's add the header, which can be a function that returns the headers or the header object itself, and call authorization and provide this with a value 0. So this would be the user with the ID 0, just for demonstrations purposes. That's it on the client side. So on the server, what you want to do is you want to create a context that checks the user ID and then makes the entire user object available for all downstream handlers. So our get user, our create user knows which user is acting on this endpoint at that point in time. So let's go to our server and implement the context handler there. First off, let's create a create context function. And this function will be called on any request before it gets passed on to the handlers. This create context will take in some options, and these are the create context express options or create express context options. What these options contain is really just the request and the response object. For us, it's especially the request object, which is interesting because this request object contains the headers and our authorization header. Let's cast this to or assign this to our user ID and make sure that this user ID is actually set. So if we don't have a user ID, then we can throw a new tRPC error. And this tRPC error is something that our tRPC client, on the other hand, can handle gracefully. tRPC errors contain a code where we can use the unauthorized, which essentially is the equivalent of an HTTP response of 401 or 403. Or 401, and add a message. In this case, no user ID was provided. And this will immediately stop the execution and kill the request. Now we can identify the actual acting user by looking at our user list and finding the user where the user ID matches the user ID. And in this case, user ID is a string because all headers are always transferred as string. So we can simply cast this to a number. Once again, we can return or throw a new error if there is no user, with the error message, no matching user was found. Finally, we can return an object which will be available in form of the context for any downstream handlers. So let's return an object. And what we can do is we can destructure the options that we get from the express context options so that downstream handlers will have access to the initial request coming in. And we can also pass in our user object. So remembering back what the documentation told us is that we have to chain in a tRPC with context. And we need to assign a type to context. Now, there is a helper function provided by tRPC, which is the infer async return type. And then we simply add the type of create context. What this does is it usually, when you would have a create context function, you would probably perform things like database lookups, so asynchronous operations. Of course, you only want to pass the request down to your downstream handlers once those have completed. And then the return type of your create context would be a promise of some sort. And this infer async return type essentially unwraps that promise. But if you're just returning a plain JavaScript object that isn't a promise, this will also work. So it's always a safe bet just to use it. Finally, Visual Studio Code is already giving us an error that this is missing the create context, which we can just call here. Now this will make sure that this create context is called anytime that our tRPC router gets a new request. The impact of this we can, for example, implement in our list users, where we have, aside from our input, we also have the context as part of the request coming in here. And what we could do before returning our list of users is actually console.log the requesting user. And this is part of the context option where you see the request and response that we forwarded and also the user itself. In this case, we probably just want the name. Awesome. That's it. So in order to test this out, let's kill the server and restart it. And on the client, we can run client. Now we see that we have the get user by ID, create user, and list of users pass as expected. And on the server side, we have the information requesting user John. Now let's say, for example, that we have a client that didn't pass in any headers. So let's comment these out and repeat the request. In that scenario, we get the 401 unauthorized with the message that no user ID was provided. Currently, we don't handle any of the error cases, which of course in a usual application you would. So before we wrap things up, there are two more things I want to draw your attention to. One thing is that our tRPC server doesn't really have a nice structure to it. So list users, get user by ID, create user, they're all on the very top level. So the way you would call them is client dot and then the appropriate function. What you would probably want to do in a more complex scenario is you would want to split those things up into separate files and also have different namespaces. So for example, instead of client.listUsers, we would call something like client.users.list, so that if you have other entities, for example, to-do, statistics, etc., then those would be easier to manage and also more friendly to use for yourself or your team. How you would approach that is if you look at the documentation under merging routers or merging routes, they have a bit of an explanation of how you can split that up into different files by exporting the router and procedures of your init tRPC, and then reusing that in different files in order to actually nest your operations in different namespaces. So for example, here we have routers/post.ts, where we have a create or list operation for the posts. And then these would be imported in the main app_app.ts just by convention. And you would have your main app router, where that would be nested in your router itself within the post namespace. So that makes your entire application a lot easier to manage, a lot more convenient to code, and also a lot more convenient to use on your client side. The other thing I want to draw your attention to is middlewares. If you've already used anything like Express, for example, you are already very familiar with the middleware concept. And in a way, how we have created our context is pretty much a middleware. The main difference is that create context you can only call once before any middleware or any handlers are initiated, and then middlewares can easily stack on top of each other. And within the middleware, you actually have access to the context object itself. So that is something to look into for more advanced authentication or authorization issues. And you can apply different middlewares to different procedures. So in this example that they provide, they create an admin procedure by using a specific middleware on this route, and then having a public route, in this example foo, by just using the standard procedure, and having a secure admin route, which is secured by the isAdmin middleware. So those are two things that in a production setting you will probably want to use to make sure that your app is secure and have an overview of what is actually going on in your application. If you've made it this far, congratulations. You now understand all of the core concepts of tRPC and how to implement tRPC in your very own full stack application. If this video has been helpful to you at all, I would greatly appreciate a like, as it really helps out this channel. We have mostly covered the server-side stuff today, as it is conceptually the most difficult thing to wrap your head around, and it is also where you will write most of your tRPC specific code. On the client side, you have a few config options to play around with, but essentially you can treat a tRPC request on the client side as you would treat any other backend request. There are even some convenient wrappers around things like React Query, which introduces neat interfaces around request state management, error handling, and automatic refreshes. Let me know in the comments if you would like me to dig deeper into tRPC topics in the future, and definitely subscribe for future updates. I'm excited to see what you will build with tRPC in the future and how it improves your developer experience. Thanks for sticking around until the end. See you next time, and happy coding!